Hi everyone, welcome to lecture number 2 of probability. We are doing GATE Data Science and AI course. So in this lecture we will see a new concept called conditional probability. In the last lecture we have seen some basics of probability, axioms, how to calculate probability of a certain event. In this lecture we will expand our knowledge to a slightly different concept which is called conditional probability. Let's see. So we'll start with an example. Suppose that one rolls a pair of dice. Okay, if you are rolling a pair of dice, we know that the sample space consists of 36 outcomes. You can get 1 on both, 1 2, 1 3 and so on up to 6 6. Okay, so you have 36 possible outcomes. Okay, these are all 36 outcomes possible, right? So they can be written like this in set notation as well. All ordered pair I comma j, where I can be 1 2 3 4 5 6 and j can be 1 2 3 4 5 6. These are all possible 36 combinations or 36 possibilities we can have when we throw two dice together, right? This is our sample space or the universe. Now what is the probability that the sum of the two dice equals 8? The sum is equal to 8. So you are given an event E. Sum is equal to 8. So what is the set? Okay, so you can have 2 comma 6. See, if you have 1 on the first die, you cannot have any number on the other, so that the sum is 8. 2 comma 6, 3 comma 5, 4 comma 4, 5 comma 3 and 6 comma 2. Right? These are the 5 possible cases which give you the sum as 8. So we know that the probability of event E will become cardinality of E upon cardinality of S. There are 5 outcomes out of 36, which gives you this. Okay, this we have seen. Now there is some other information given. This was standard probability. Okay. Now what makes a conditional probability is this. Suppose further that we observe that the first die lands on a side 3. This is a additional information given. Okay, the first die always lands on side 3, or not always, like for this experiment they have said that the first die gave you 3. This is an additional information given. Now given this information, what is the probability that the sum of the two dice equals 8? Now the problem becomes different, right? Previously we have to solve the generic case in which we have thrown two dice. What is the probability that you will get a sum of 8? Now they have said that the first dice has given you a 3. This is a condition which is already given. So now, given this information, your sample space reduces. Always in conditional probability, when some condition is given, basically your sample space gets reduced. Given this information, what happens? Your sample space only becomes this: 3, 1, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. Since the first dice has landed at 3, now your sample space is not the entire 36 elements, it's only this 6 elements. This is the updated sample space for your experiment now. Now what is the probability of getting a sum of 8? This is the only case which will give you a sum of 8, right? So the probability will become 1 by 6. See, observe that the probability is not 1 by 36. Since it is given that first die has landed in 3, your sample space is also reduced. The common mistake which people do here is, they say that the first die has given 3, so now the only combination possible is 3, 5. So they will do 1 by 36. You don't have 36 outcomes in sample space now. Since this observation is already given, that the first die landed in a 3, your sample space is now just 6 elements. And that's why the probability is only 1 by 6. Right? So given this information, the sample space reduced. So coming to notation, if we let E and F denote respectively the event that the sum of dice is 8 and the event that the first die is 3. So now we have a few events. E is the event that the sum is 8 and F is the event first die gives you a 3. First die lands in 3. Then the probability just obtained is called the conditional probability of E given F. The probability which we just calculated. The probability of getting a sum of 8 given that the first die landed in 3. It is called the conditional probability. Conditional probability of event E given that F has already happened. Conditional probability of event E given that event F has already happened. Right? It is denoted by P E by F. So if the event F occurs, it is sure that F has occurred. Then in order for E to occur, then is necessary that the actual occurrence be a point in both E and F. Firstly, there should be some intersection, right? In E and F, there is some intersection. The element 3, 5 was an intersection. Otherwise, like if F happened and there was no intersection in E, then the probability will be 0, right? And we know that this intersection is called E intersection F. This intersection is called E intersection F. All the elements which are both in E and F, this is called E intersection F. Or you can call it EF as well. Now, since we know that F has occurred, it follows that F becomes our new reduced sample space, and that's why this is the new probability. So that's how we calculated it. See, in event E, the event E was what? Sum is 8. We know that there were 5 elements here: 2, 6, 3, 5, 4, 4, 5, 3, and 6, 2. There were 5 elements in set E. Sum is 8. What was event F? That the first die gives you a 3. So what is the sample space? What is the set F? What is the event F? 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. 6 elements, right? Now, since it is given that F has already occurred, it is given that F has happened. Now your universe becomes this. Since it is given that F has happened, your universe becomes this. Your sample space becomes this. What it means that all the elements in E which are not in F are of no matter. They cannot happen now. Since F has happened, all the elements in E which are not in F, they can never happen. Since it is given that 3 happened in the first die, you cannot have 2, 6 at all, right? So all these elements are useless. Only the elements which are also in F, they are useful. That's why we calculate E intersection F. The elements which are in both E and F. These are the only elements which can happen and they satisfy our condition. What is E intersection F? The only element is 3, 5. Right? So this is the only element. Now this is our new event probability. This is the event that we want to happen. This is not, previously this was the event that we wanted to happen, that probability of getting a sum of 8. But now this is the event that we want to happen, 3, 5, right? And now since the universe became F, I told you, like since F has already happened, our universe or sample space became F. So that's why this condition probability of E given F has already happened becomes probability of E intersection F, upon probability of F, right? So we divide by P of F because F has already happened. That's why like we divide by this probability. Like this is our sample space now. Okay? So this is how condition probability is defined. Probability of E given F has already happened is probability of E intersection F upon P of F. Okay? Let's start to solve a few examples. So on rolling a die, what is the probability of getting a prime number given that an odd number showed up? Okay? So we will solve both using directly formula and using our naive way. So let's say E is the event of getting a prime number. What is the set? 2, 3, 5. And let's say F is the event of getting an odd number. With what is the set? 1, 3, 5. So firstly, generally speaking, what is the probability of event E? The probability of event E is 3 by 6. So this is our original sample space. When you roll a die, the sample space is 1, 2, 3, 4, 5, 6. Right? Now, the probability of just happening of event E is what? Getting a prime number. The cardinality of E, 3 elements out of 6 elements, so 3 by 6, which is 1 by 2. Probability of just happening of event F, of getting an odd number, is also 3 by 6, which is 1 by 2, since it has also 3 elements. Now, but they have changed the question. They have said ki, given that odd number showed up, now this becomes our universe. Given that odd number shows up, this becomes our universe. Now this becomes our sample set. So what we want now, given that F has happened, what is the probability of E? So firstly, we will calculate E intersection F. Since F has already happened, 2 is of no matter. You will never get a 2. Since odd number showed up, only 3 and 5 might come up. Right? So that's why probability of event E, given F has already happened, is, now this is your set, event, and this is your sample space. So it becomes 2 by 3. You have 3 elements in sample space and 2 elements in the event, right? And formula wise also, what is the probability of E intersection F? What is the probability of E intersection F? E intersection F contains 2 elements. So 2 by 6, which is 1 by 3. So the formula wise, probability of E given F has already happened is probability of E intersection F given probability upon probability of F, which is 1 by 3 over 1 by 2, which is 2 by 3. Okay? So that's how you solve conditional probability. Now let's see another question. The experiment is rolling 2 die together. So the sample space contains 36 outcomes, 1, 1, 2, 1, 6, 1, 1, 2, 6, 6. There are 36 outcomes. Okay. Now an event E is given that both die showed an odd number. Both die showed an odd number. So there, what is how many elements will be there in E? Think about it. Both die showed an odd number, which means that E will be what? You can have 1, 1, both are odd. You can have 1, 3, you can have 1, 5, and you can have 3, 1, and so on. At the end you will have 5, 5. Both die should have an odd number. So you have 3 odd numbers. So 3 into 3, there will be 9 elements. Since initially when you have 6 elements, you had 36 cases. Now you have only 3 elements. Only 135 can be on the first place, 135 can be on the second place. So there are 9 elements in the event E. And the event F is given to be sum of the numbers showed is 6. Sum of the numbers showed is 6. So what is this case? 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. These are the only 5 cases, 5 elements. Okay? There are 5 elements in set F. Now we want to calculate probability of E given F has already happened. So given that the event F has already happened, which means that it is given that the sum of the elements was 6. So now this becomes our universe. So we can use the formula directly. Okay, let's calculate E intersection F. E intersection F will be what? The elements which are common in both of them. So basically both the numbers should be odd here. So 1, 5 is one such case, 3, 3 is one such case, and 5, 1. This is our intersection set, 3 elements. Okay. So now probability of E given F has already happened is what? Probability of E intersection F upon probability of F. Probability of E intersection F is what? There are just 3 elements out of 36. And probability of F is what? There are 5 elements out of 36. So this becomes 3 by 5. And similarly, probability of F given E has already happened will become probability of F intersection E upon probability of E. Since intersection is commutative, you can P of E intersection F intersection E, E intersection F is same. So this will become 3 by 36 upon probability of E. E has 9 elements, so 9 by 36. So this becomes 3 by 9 or 1 by 3. Okay, logically also if you see, what is probability of f given e has already happened. Given that both numbers are odd, so there are only 9 such cases. Out of these 9 cases, how many have sum as 6? How many of them have sum as 6? So only 3 have sum as 6. 1, 2 and 3 out of these 9 elements, right? So that's why 3 by 9 or 1 by 3. So like logically also you can say, or you can use the formula. So this becomes 3 by 5 and this becomes 1 by 3. Okay. So now let's solve a question. A bin contains 3 defective. A bin contains 3 defective that are immediately fail when put in use. There are 3 defective, 5 partially defective and 10 acceptable transistors. There is a bin which contains 3 defective, 5 partially defective and 10 acceptable transistors. So there are 18 total transistors in a bin. Now a transistor is chosen at random from the bin and put into use. If it does not immediately fail, what is the probability that it is acceptable? So let's say there are 2 events. Event E is one event is it immediately fails. Immediately fails is not defective. See, immediately fails is defective only, right? In brackets. So probability. So let's say event E is the transistor is defective. And the event F is, we have another event in this question, that it is acceptable. So see, all the like in any question, just make events, then it will be easier. Event E is, so it says that it does not immediately fail. So you can ignore the not right now. While creating events, don't worry about not, because when solving the question, after events are created, we will just use complement, right? So they said that if it does not immediately fail, so we made one event as the transistor immediately fails, which means it is defective. And the other event is, we want to find the probability that it is acceptable. So the other event that we will create is that the transistor is acceptable. We know that there are 3 transistors which are defective, and we know that there are 10 transistors which are acceptable, and the size of sample space is 18. So it's very easy to find the probability of E and F. Probability of E is what? 3 by 18. Probability of F is what? 10 by 18. But that's not what you want. What you want, now read the question very carefully. Once you've created the event, the question will become very simple. See, given that the transistor that we pulled out is not immediately failed, does not immediately fail, it means that E complement happened. It does not immediately fail. It means that E complement happened. It means that it was not defective. It was either partially defective or it was acceptable. E complement happened, right? It was either partially defective or it was acceptable. Given that E complement happened, what is the probability that it is acceptable? So what we want to find is, just if you create this equation correctly, then your answer will be good. This is what we want. Given that the transistor was not defective, what is the probability that it is acceptable? So what it will be? It will be probability of F intersection E complement upon probability of E complement. Right? Now what is the probability of F intersection E complement? What is this set? F intersection E complement means what? That it is acceptable and it is not defective, which means it is either this partially acceptable or acceptable, right? That's what intersection is. No, sorry, what is F? It is acceptable. What is E complement? E complement is partially acceptable or acceptable. So E complement is partially acceptable or acceptable. F is what? Acceptable. So what will be their intersection? What is the common element? Acceptable. Right? Their intersection is nothing but acceptable. So this is nothing but acceptable. And the probability of E intersection F intersection E complement will be what? 10 by 18. Right? So what is this probability? This will become 10 by 18 upon, what is the probability of E complement? The probability of E is 3 by 18. So the probability of E complement is what? 15 by 18. Given that E doesn't happen, which means either this happens or this happens, which means there are 15 cases, 15 by 18. So now this is our probability. It is 10 by 15 or 2 by 3. If you make this expression correct, then the rest question will be very simple. Okay. So read the question carefully, make the events very carefully. Or you can also make here, you can make the event E as the transistor is not defective. In that case, you will have to calculate F by E. Then the events change. So depending on your event, read the statement carefully and make the expression. Then it will be easy. So the probability is 2 by 3. Okay. Let's move to the next problem. So I'll read the question. Mrs. Perez figures that there is a 30% chance that her company will set up a branch office in Phoenix. If it does, she is 60% certain that she will be made manager of this new operation. What is the probability that Perez and Phoenix will be a Phoenix branch office manager? Okay, interesting question. So here also we will have to make events very carefully. There are a few events given. The first event given is that her company will set up a new branch in Phoenix. This is the first event given, and there are 30% chances of that. So the one event given is company sets up a new branch in Phoenix. Okay, and it is given that probability of this event is 30%. There are 30% chances. If it sets up a new branch, she is 60% certain that she will be made a manager of this branch. So it is like, if E happens, then probability of her being a manager is given to be 60%. So the other event F should be what? F should not be if and like, see, this entire event is what? If the company sets up a new branch, then the probability is given. So it is like probability of something by E is given. Probability of her being a manager given a new branch is set up is given. Probability of her being a manager given that the new branch setup, given E happens, is given. So what is, let's say the event F is like she becomes office manager. She becomes office manager. This we don't know, but it is given that she will become a manager given that the company sets up a new branch. This is given to be 60%. I hope you got it. If the company sets up a new branch, she will become a manager with 60% chances. Now what they want, what is the probability that Perez will be the manager? So we want probability of F. P of E is given, P of F is to be calculated, and P of F by E is given. So it's a slightly different question. But yeah, we know the formula. P of F by E is P of F intersection E upon P of E. Right? Yup. So it means that P of F intersection E is 6 by 10 into probability of E, which is 3 by 10. Okay, which is 18 by 100, which is 0.18. There are 18% chances. So this whatever we have calculated right now is P of F intersection E. What is F intersection E? F intersection E is company sets up a new branch in Phoenix and she becomes office manager. That's what we wanted also. We actually didn't want P of F. Read the question carefully. What is the probability that Perez will be a Phoenix branch office manager? It is not saying any manager. It is saying Perez will be Phoenix branch office manager. It means that both events happened. Company has set up a new branch in Phoenix and she became the manager. So actually we wanted this only. Right? And this is what we have calculated, 0.18. Okay, I hope you got it. So we didn't just want we just didn't want the probability of she being any manager. We want her to be the manager of Phoenix branch office, right? And that's what PF intersection E is. P of F intersection E is, right? Both the events are happening. So there are 18% chances that she will become the manager of this branch. Okay. Moving on to the next question. This question has been asked in GATE 2010 in computer science. So a box contains 4 white balls and 3 red balls in succession. 2 balls are randomly selected and removed from the box. Given that the first removed ball is white, the probability that the second removed ball is red is. Okay. So like see, generally speaking in probability, don't mug up the formulas. Conditional probability, if you mug up P of E by F is P of intersection F upon P of F, and you keep mugging and then keep multiplying, nothing will happen. Okay, it will be very tedious for you to solve problems. Try to logically feel like how it is derived. What is conditional probability? It's very obvious, right? Given this event has happened, what is the probability of this happening, right? Now the sample space has reduced. So you can logically think about problems. And even in counting, when we discuss so many things, I gave you proof of almost every formula, inclusion, exclusion, how it works, dearrangement, how it works, right? Multinomial, binomial theorem and the relation of them with combinations. So try to see the connections and try to derive it on the spot. Okay, you won't be able to remember everything. See, this question can be solved using formula. It will take writing a formula, generating events. It will be a lot of time. But see, very obvious question. If I forget about every formula, it's just very simple common sense, okay? A box contains 4 white balls and 3 red balls. This question just requires 30 seconds, trust me. 4 white balls, 3 red balls. In succession, 2 balls are randomly selected and removed from the box, one after the other. We select one ball and then we select another ball. So basically we are not replacing them. So given the first removed ball is white, it is given that the first removed ball is white. Okay, like the first removed ball is white. Now what happens? The bucket becomes 3 white and 3 red balls. Given that the first removed ball is white, now the bucket becomes 3 white and 3 red balls. Now what is the probability that the second removed ball is red? So now the box becomes this. So what is the probability that the second removed ball is red is 3 by 6. That's it. That's it, right? Logically thinking, this is the problem. But now, like if you want formula, so like you will have to generate events. Event E is what? First removed ball. Since we are drawing 2 balls, the sample space is what? Sample space is white, white. The original sample space. You can get both white. You can get first white and then red. You can get first red and then white, or you can get first red and then second red. This is the entire sample space. The event E is first removed ball is white. First ball is white, and the event F is second ball is red. Okay. And the event F is second removed ball is red. Now we want probability of F given E has already happened, which will be probability of F intersection E upon probability of E. So firstly let's calculate what is the probability of E. What is the probability that the first removed ball is white? What is the probability that the first removed ball is white? It is 4 by 7. Since there were 4 white balls and there were 7 total balls. Since there were 4 white balls and there were 7 total balls, the probability of first removed ball to be white is 4 by 7. Now what is the probability of F intersection E? It means that what is the probability of first removed ball to be white and second removed ball to be red? So this probability will be what? So first removed ball is white and second removed ball is red. First removed ball is white and then the second removed ball is red. So now this and this will cancel and you will get 1 by 2 only. Right? Formula wise, like if you do conditional probability, it will be tedious. But like if you just do logically, like first removed ball is white, so now the sample space becomes this, right? That's what happened here as well. Then the probability becomes 1 by 2. Okay? Cool. So these were a few questions on conditional probability. Now if you rearrange this theorem, conditional probability, you will get another very beautiful theorem which is called multiplication theorem. So that we will see in the next lecture. So for now, this is about conditional probability. Thank you so much.